Hi. Just go ahead. Yes. Hi, I'm Julian, and I'm going to tell you a little about offline transactions, especially Payala. Okay. So I'm going to introduce to you Payala, which is our technology, and give you some thoughts about how I think we can integrate with Moduloop and talk a little about offline transactions and how we solved this. To structure this talk, how does this arrow keys? No, it doesn't. Okay. So I'm quickly going to talk about who we are. Then I'm going to talk about what Payala is and give you a quick demo video. Then I'm going to quickly talk about how I think we can integrate technically with Moduloop. Talk about how I think the financial integration and the financial architecture should look like, and then why I am here and what our ask is to you. We are Financial Empowerment Partners. That's the company. We're a US-based private sector company. We're constructed out of, set together out of experts in cybersecurity, finance, public policy, and all of us, our co-founders, have real-world operational experience in the appropriate environments. We actually know what we're doing and why we're doing it. That's what I'm trying to say. And we developed Payala. Now, I personally am Julian Finn. I'm based in Hamburg, Germany. I'm the CTO and co-founder, and I helped lead the team to create our technology in the last few years. Payala is a peer-to-peer payment system that is secure, that is resilient, and that is inclusive. And that means that it works in intermittently offline scenarios. It is designed for challenging environments, not just for rural areas, but also, for example, for natural disaster, for disaster relief, and for active threat scenarios, and designed for marginalized communities like refugees, etc. It's designed to help ease the liquidity availability problems within these communities. And it is designed for low cost and light infrastructure footprint, which means that it is designed for environments in which the network does not always work. It is designed for communities in which not every person can afford their own smartphone. How does that work? Well, every user holds their own smart card, and that constitutes their account within the system. They don't need their own smartphone. They can use any smartphone that has NFC and currently Android. These smartphones act merely as terminals, as transport layers for the transaction that happens between the smart card and either the server in an online environment or two smart cards in an offline environment. So we have basically three transaction modes. One is, depending on the connectivity. One is remote. That means I would enter a user's ID, phone number, whatever lookup mechanism I have, and send them money remotely. They would receive an SMS, go to the next terminal, pick that money up onto their card. The second is local and online, meaning me going into a store, traditionally paying in that store with my card towards the store owner, and that store owner then automatically synchronizing with the server and receiving that money. And the third one is, and that's the most important one, that's the one I'm focusing on, is local and offline, which means every user has their card and transacts between one card and the other. To give you a quick overview of how that works, this is a quick video, the 90 seconds video of how the user experience works. So I have a quick yeah. So I've got to quickly jump within the slides because something went wrong there with the saving of the file. Just focusing on the offline transfers, the transfers are basically stored on both smart cards as well as the transacting phone. And whoever gets online first then synchronizes back with the server. So either the phone gets back online, regains connectivity, or one of the two users takes their smart card to another terminal and then uploads that transactions to the server, synchronizes with the server. The card itself is the authoritative wallet. So whatever happens with that actually creates the funds transfer. It's synchronized whenever the connectivity is restored, and to prevent duplicate spending, we use limited use keys that are issued by the central authority, by the server, by a hardware security module, and stored on the cards in a limited amount. So, for example, arbitrary amount. Let's say we have 20 keys stored on one card. That means you can perform 20 transactions until you have to regain connectivity. And each limited use key, one-time key, is allowed to perform one transaction, and the server will only recognize this one transaction per key. And we can also constrain offline amounts in cases where we consider that useful to make sure that people don't lose their entire money with some form of fraudulent transaction, just as sort of a backup mechanism. So that's the basics of how this works. I will obviously answer questions later. The question is now, wait a second, how to integrate with merge loop. Our system is more or less closed policy, and I think that should stay that way for various reasons. First of all, we are a proprietary system, so we have to attach to merge loop from the outside in order to not break software licensing. But also the monies need to be kept separate, because if we are within the system, we will eventually get into regulatory trouble for some way. So the money needs to be separated out, placed on the cards, and then resynchronized back when we regain connectivity or whenever we want to cash out. To my basic idea of having had a look at merge loop with my team, and my basic idea of how this should be working is to have the authoritative storage of the accounts within the merge loop hub, and using the account lookup service as a synchronization mechanism onto our own system. So every account that is within the merge loop hub that is marked as using Payala is then synchronized to our system. We have our own ledger, we have our own account data, and we extract money onto the cards, and we mirror that onto our system, but we don't back propagate, we don't update from our side. Therefore, our system has the user, and then the users can transact with each other, and then the money is given backwards. So money is separated, as I said. We have an entire offline transfer and eventual sync system. The money can be immediately be respent. So me receiving money in an offline environment means that I can, and that is compared to other systems, I think fairly unique, can also immediately be spent onwards. And then cashing out just works backwards. I'm always clicking on the right mouse button. So the way this would work for us is that basically the merge loop adapter creates a transfer at a fixed rate and is also accepted into our transfer API, and therefore creates a mint function, which means that our system now creates money out of nothing, mints money in our system. The money is then would then be stored into an escrow account that would be holding that money until it is then stored back in the merge loop system. In an online environment, that would happen immediately and completely transparent to the user, right? In an offline environment, that would mean that money is then stored on the smart card, paid around in the system, at some point gets back into the and settled with the merge loop system. The money would be reserved by the financial service provider until it's loaded onto the smart cards. The funds that are minted into Payala are held in escrow accounts, as I said, and it would also ensure that the transfer never result in a negative balance, because the money is basically separated out and kept somewhere else, and therefore cannot be reused in an online environment, sort of if you have auto-paying mechanisms or even other functionalities that would, or have dual accounts. So a user could then have an online account, a savings account, with which they do all sorts of things, and then subtract money to put on their card and to use in an offline environment. We could also, the other option is to, this could be done with a user interface. The other option is to automatically store all money on the card and use depending on the scenario. The money would then be within our system, transferred from the mint to the recipient, stored on the phone, transferred on the card. That's where it lies, and then the whole system runs in reverse once it is synchronized. This slide I already had. That was my hiccup here. The cashing out would just happen in reverse, meaning the money would move out of Payala, destroyed in our system, move back to Mojaloop, move out of the escrow account, and then be used within the Mojaloop system. And that would all happen to more or less have to happen at fixed fees and especially at auto-accepted transactions, in order to make it transparent for the user. At least that is my current understanding of it. That is a very quick run through of the system. I'm very happy to show everybody how it works in real life later. I'm also happy to talk about, any kind of questions. I'm now going to quickly talk why I am here, right? We're very open to talk. We created this system exactly for the environments that you folks are working in. We piloted in Timor-Leste the first time. I've been showing this system to a couple of you folks and have been so far received very welcomingly. We believe that our system can benefit very many people in countries like Tanzania, in countries like Myanmar, in all these countries all around the world where infrastructure is very centralized towards the cities and works great in the big capitals, but gets more sparsely as further out in the countryside as you go. And where, for example, a simple electricity outage means the loss of connectivity for potentially hours and very often throughout the week. And if you want to fully rely on digital cash to live your life, you will end up with problems if you suddenly are unable to buy groceries on the market because you can't transact, and I'm pretty sure you all know that. So we piloted this in Timor-Leste with great results. It was very well received by the local communities, as well as by the government, by private organizations, by NGOs, by MFIs, by banks. Everybody loved it. We were in the process of lining up investors, and then March 2020 happened. Guess what happened there? And then the entire system sort of, that's when, that specific project didn't happen anymore. But we're in the process of, gaining traction within the community. We're looking for partnerships. We're looking to talk. And basically our goal is to go country by country, building entire ecosystems together with you folks. So I'm here to the end of the week. I'm happy to have conversations with you. I'm happy to talk, to listen, to explore, potentially seek funding together, potentially explore options together. And if you want to ask questions, please go ahead. I'm sure I missed a lot of things that you might be having question marks about. My name is Julian Finn. You can reach me at julian@payala.com. You can reach me anytime you find me. And yes, thanks for listening.
Excellent. Any questions? I see a couple. So 1, 2, 3, 4, 5. Wow. All right, we have 13 minutes. I'll give each question a minute and a half each. Jean-Claude, we'll start with you.
Okay, yeah.
Thank you so much. I wanted to see to understand whether it requires both the payee and the payer to be together just to execute an offline transaction.
Yes.
Okay.
Because otherwise there's no data flowing. So
Okay.
you need to get the data together somehow. That's
So if someone is
NFC.
in a remote area, that means he has to do a distance and then.
So you have one phone has to be present. It doesn't need to be either the payer's or the payee's phone. It can be anybody's phone.
Okay.
It can be off. It can be offline, right? It needs to have Android right now. We're working on an iOS version, but given the environment, it's not entirely so important to have iOS. It needs to have an NFC interface. Both users tap their cards to the phone. That's how they transfer money. If they are online, you can, for example, enter a user's phone number or any other identifier, depending on the environment you're in. Phone numbers are a good idea or a bad idea, but you enter the user's identifier and send them money, tap your card to authenticate that transaction. The user on the other side of the country or possibly in another country receive an SMS, say, you got money. They go to the person with the next phone, they tap their card, and that's how they receive the money.
All right. So what happened when the card is lost while having some offline transactions?
Thank you. That's the most often answered question. So if both cards and the phone are lost at the same time, then there's no record of that transaction ever having happened. However, if one card is lost, then the user owning that card can theoretically go to the next agent, identify themselves, regain a card, and that is entirely a policy question how you want to do it. Do you want to attach a fee to that? Do you want to, do you want to penalize that person in some way, or how do you want to do it? That's entirely up to the program. The transaction will be regained through the other phone or the other card, right? As long as one of the three elements is still there, the transaction will reach the server at some point, and then that will happen.
Sorry, Warren, do you want to go? Right.
Thanks, Julian. So this is very interesting. I'm sure some of us have noticed that the flows you had there are not quite the merge loop.
Yes.
Merge loopy correct way of looking at it, because it's more that this would be a DFSP on the side and stored value in that. But I think the principle is great, and we can actually facilitate that. So my actual questions, I snuck in over there because I wanted to check that the phone the phone itself didn't need to be offline. So I'm going to online. I mean,
yes, exactly. The cards only get connectivity by the phone anyway.
Yeah.
So the phone can be offline.
Okay. All right. I'll leave it for now and come back to you.
Cool. Thank you, Julian. That was a really compelling use case here. My question kind of is a bit on Warren's question. You talked about integrating directly with Modular Loop, but that was the example outlined here. I understand why this needs to be a closed loop system, given the offline nature and the other sorts of requirements you have here, and the fact that Modular Loop is real-time payments. Those things don't seem to play well together. And I do somewhat understand your concept of the escrow, having some sort of amount locked up in escrow and then periodically settling that back. What's the value of integrating directly with Modular Loop versus this being a product that you would approach a bank or a mobile money provider to partner with them to offer this?
It depends. It depends on the environment you're operating. If you need to be there would need, depending on the environment, you would need some kind of financial service provider license anyway, right? But depending on where you're at, it appears to me that Modular Loop as a switching functionality, might integrate well. talking to a specific bank would then potentially only, instead of acting as a separate environment. I mean, that's policy question, and essentially, I think it's both possible. Yeah, if I don't know what is the largest public bank in Tanzania, but if they were to simply license out our system and do their own thing, and then they would attach to merge loop, it's theoretically the same kind of thing. But we are, as a technology provider, we're more independent of that. We're seeking partners, and that can be a bank, that can also be any kind of other system that, for example, interacts with merge loop in a country.
Yeah, cool. Thank you. And Michael, perhaps they could be a PISP, just to boggle the mind even more.
Can you see the hand? Yes, go ahead.
Hi, this is very interesting to me, especially for where our strategic plan for a company is. I'm from UBX and we offer financial services, agency banking, mobile banking, and I see this as a very integral part to the services that we offer. But my big question is, what kind of card does that have to be? Is it a closed loop card? Can it be a Visa card?
Right. It is its own, it's a standard Java card based smart card.
Okay.
The costs to produce are depending on volume and the low digit dollars, right? I can't give current numbers because we have a massive global supply chain issues around silicon, but there used to be like $1 something for a million a piece, right? And they need to be specifically ordered. They're not, they can't be a Visa or MasterCard. They have their own software on them. And the way Visa and MasterCard work is that they would not allow a competing system on their cards. But these would be their own cards. It would be its own system. Yeah.
Okay, so we also have our own cards called the Umoja Switch cards.
Mm-hmm.
Is it, because I'm very flexible in terms of saying, let me enable my card onto your platform. Is that a possibility?
If the card runs global platform, it is, yes.
Okay, last question. What about feature phones?
No. Feature phones, unfortunately, I'm not aware of a single feature phone, and please correct me, anybody, if there exists. I'm not aware of a single feature phone that has an NFC adapter or stack, and it needs the NFC to do so. If someone were to jump through a million hoops to attach a external NFC reader via Bluetooth to a Bluetooth-enabled feature phone, it's theoretically possible to do so. However, that's a lot of programming work. It's not designed to work with the feature phone right now.
I think that's the challenge for all of us in this room, because in Tanzania, that's most of what people use, the feature phone.
But so just to answer this question in a different light, not every user who takes part in the system needs their own smartphone. So basically what happens is, the scenario that I would see is you have agents that, order a stack of cards that do some basic KYC requirements and hand out cards to users. And people who have smartphone then become their own sort of transacting agents. So either they have a store, they buy cheap smartphone, the cheapest smartphones that have NFC and appropriate Android are in the double-digit dollars nowadays. And those who are capable of performing transactions could then somehow benefit from these transactions as well, become their own agents. Micro agents, like larger persons, and people who simply own a feature phone would be able to receive information about their balance. For example, you received money via an SMS. And that would inform them of what is happening, but they would need another person's smartphone to transact, but that is possible. So they could go to a store, or say we have a local market situation somewhere on the countryside. I want to pay with my card. The farmer selling me their groceries doesn't have a phone. There would be someone around the market having their own phone. I call them up, say, hey, I want to pay. And then they make 0.5% of that or something, there's models around that you could think up.
All right. I have 3 minutes. Can I give? Wow.
4 more questions.
Just one more question, if you don't mind.
Okay.
Sorry.
Stephen, we have it.
Sorry, guys,
We'll
time.
talk later.
If you have any other questions, just post them on Slack and then we can ask you
Yes.
to add on there.
Hello, everyone. This is a fast question.
Sorry, I can't. Are they you? Okay, sorry.
Due to the nature of the NFC itself and the active passive mode, let's say, for example, I want to transfer money to you directly.
Yeah.
We still need the middleware, let's say, for the active mode. Would the transfer or the fund will be available immediately if
Yes.
that middleware is in offline mode, or I have to wait for synchronization with the server
If we're in the same location,
in the same location? For example.
yes, if we're in the same location and I transfer money, it is basically transferring data from one card to the other card, and it's immediately available.
Even if the middleware is still offline and there is no need for
Yes.
synchronization.
If we are in different locations, then the data has to flow somehow. So
for
then
the server.
obviously have to wait. Yeah.
Thank you very much. Thank you.
Michael, I'll give you the last question. We've got literally 1 minute.
So I think actually you've answered a fair amount of what I was going to ask. I'm assuming that in order for a smartphone to be able to act as a mediator between these card transfers, it would have to have your application downloaded onto it.
Yes.
Yeah, I thought it would. And my worry then is that you've got potentially quite a complicated business model where if effectively you're asking third parties of various kinds to support the execution of these transfers, but as far as I could see, no very obvious way of allowing them to say, and by the way, I intend to charge 5% or whatever it is for facilitating the transfer. Or did I misunderstand? Did I misunderstand something?
So yes and no, it's a very good question. Let me quickly try and clarify the idea I have in mind. And keep in mind, these are essentially policy questions, right? You can completely do it differently if in the process one would figure out that different way would work or not. The idea is basically participants in the system who have a smartphone download the app, right? And you need to be a participant in the system to receive money via the system. However, what is thinkable is that the app contains a feature that allows a transfer agent, a person that facilitates transfers between two separate parties, to benefit from these transactions and set their transaction fee within the app. Say, okay, I click a button, it says 1%. I tell both parties, hey, it costs you 1% to transfer via my phone. They do that, I get 1%, thanks, goodbye, or 2 or whatever. That is thinkable, whether that is the way to go, that is an entirely separate question, but it is thinkable to make individuals who are not party to the transaction still benefit from that transaction in some way, right? They could also pre-negotiate, they could just make it automatically. They could also do it for the greater good if they feel like it, right? But
so it sounds like you've just made purchase of a cheap smartphone a good business investment decision.
Yes. This is another thing, right? Theoretically, the program could subsidize smartphones and then pay that off via people, cashing in from performing transactions for others, right? You have to you get a smartphone for free or cheap, and then you after the 5,000th transaction, it belongs to you. Something that's theoretically thinkable.
Yep. So eventually you consume all the people who don't have smartphones. It's a timeout. Oh no.
Well, they still, yeah.
Yeah.
Okay. Thank you very much, everybody. I'm here to talk next.